This talk will be presented to you by Colombia JavaScript community. So over here you will learn a lot about LLMs and how you can actually use them in your current projects. And I'm gonna pass my mic to Juan. Juan, let's start this talk.
Thank you, Pavel. For sure. Let me share my screen. I'm Juan, lead software engineer at IPAN. So I'm here today to talk about vector databases and retrieval-augmented generation. Today we will talk about large language model, how they interpret the text. We will cover tokenization, embeddings, how we can generate those embeddings, how we can apply semantic search, and how implement retrieval-augmented generation. First, what large language models actually are. Large language models are AI models often based on a transformer architecture designed to understand and generate human language, code, and more. These models are trained in vast data sets of text to capture the complexity of the human language. To understand the large language model, we need to discuss the core natural language processing task, that is language modeling, involves create models that predict the likelihood of sequence of tokens. Those models are There are two main types of modeling tasks: autoencoding and autoregressive. Autoencoding tasks involve reconstructing the original sentence from the corrupted version and allow the model to take into consideration both sides of the missing token, right? Models like BERT are ideal for sentence and token classification. Autoregressive tasks involve predicting the token based on the previous generated token, using only the decoder part of the architecture. GPT models like GPT-4, ChatGPT are autoregressive and excel in text generation by predicting one token at a time. In the world of the large language model, there are an important mechanism called attention. Attention in transformer allows the model to weigh the importance of different words in a sequence of related to each other word when each word is processed. This means the model can attend to relevant words to contribute the meaning of the current word being processed. Attention mechanism is considered the most important or the most responsible aspect for helping large language model actually learn. So, how they interpret the text. For any large language model to learn, it has to convert what we perceive as text in something machine readable. And this is done through the process of embeddings. But before go deeply in embeddings, let's check tokenization. Tokenization involves breaking text down into small units called tokens. Those tokens are pieces of information that are embedded into semantic meaning and act as input for the attention mechanism that we mentioned before, allow actually the large language model learn. Tokens are a static vocabulary for a large language model and don't always represent entire words. Sometimes represent a simple word, punctuation, individual character, or even a subwords. Have you ever saw the tokenization, the tokenizer UI that OpenAI provide? You know that you can introduce a sentence there. The UI will show you how many tokens that specific sentence contains. You can see that tokens are different of characters, and also the UI showed you how the tokenizer split the sentence in different tokens. Sometimes splits the same word in 2 or 3 tokens. Also, you can change the view, and instead to see the tokens, you can see the tokens ID. This is generated by the tokenizer to provide unique ID to each token. So now, what are embeddings? Embeddings are a representation of word, phrases, and token in a large dimensional space in natural language processing are used to represent words, phrases, in a way that capture the semantic meaning and relationship within words. There are different types of embeddings, position embedding that capture the position of the token in a specific sentence, and also token embedding, which encode the semantic meaning of a token. Embeddings provide a unique ID to capture the meaning. That a numerical ID helps the computer to see how 2 tokens are similar. For instance, knowing that happy and joyful are close in meaning, even though there are different words. So let's check on a small example. For this sentence, GenAI for JavaScript engineer, this is the generated embedding using the text embedding model from OpenAI. This is the generated vector. But how we can, as developer, generate those embeddings? We can choose, there is a lot of functions, so we can choose different models. For instance, we can choose test embeddings either from OpenAI or Mistral Embed or Sentence Transformer. There are a lot of open source options that we can use from Hugging Face to generate embeddings. So let's check an example. For today's talk, we will use, give me 1 second. I think you are seeing, oh yeah, you can see it now. We will use some utilities from LangChain. LangChain is a package that helps us to work with GenAI project, so we can use model embeddings model. We can use chat models from different vendors like OpenAI, Google, and so on. So let's import open embedding from LangChain, and let's create an instance. So once we have the instance, we can call the method embed query and pass a sentence to that method. So once we run this code, the method embed query will generate embeddings for these 3 different sentences. So let's check. So you can see, if we print the length for all 3 embeddings, you can see the length are the same, because no matter which sentence we pass here, the model will generate the same dimension vector. So this is called dimension, and dimension for embeddings means how many features a model can generate from the test that you provide. Also, you can see how a vector embeddings looks like, right? So what we can do with embeddings? Basically, we use embeddings to calculate similarity between 2 vectors, then similarity between 2 sentences. So we can use different metrics. So today we will use cosine similarity, but you should know that you can use product dot or Euclidean distance. But today we will use cosine similarity to measure the angle between those 2 vectors. So the closer the angle, the value is to 1, means the vectors are more similar. So let's define a utility function to calculate the similarity between the 2 vectors, and let's compare the first and the second vector, the second and the third, and the first and the third one. So if we run this code, we will show some score there. Remember that the values more closest to 1 means that the vectors are similar. So if you remember the first 2 sentences talk about GenAI, so they are similar. So for that reason, the score is close to 1. But usually we don't want to work with sentence 1 by 1 and then generate embeddings for each sentence. So what we can do is use loader from LangChain and load data. Let's say PDF file in your local machine or your company data. So you can load documents and transfer the documents in embeddings, and then use to find some information. So from LangChain, let's use recursive character splitter and also PDF loader. So we need to create the instance of PDF loader passing the document file, document path, and then from the instance we can call the method load. Oh, sorry. Let me import this. Yep, you can see it will return an array with an object that contains a page content key. That page content key contains all the information from the document that we already load. But usually it's not a good strategy to use the document as is, because will impact the performance, will impact the how accurate the model will generate answer based on that content. So a strategy that we can follow is chunking the document, create document chunk. So in order to work with smaller data and then provide that data to the context for each model. So in order to create a document chunk, we need to define the chunk size, and we need to define the overlay size. Chunk size is how many tokens each document generator will contain, and also means that generally each chunk will be the same size. An overlay size is a value to tell the number of tokens that each chunk will share between them. So we can share some information between generated chunks in order to avoid to lose some context or to lose some information, right? So let's create this utility function. We use recursive character splitter, and we need to pass, as I mentioned, chunk size and overlay size. This value will depend of your specific use case. So and also depend of your data, the data you are working with. So, but today we will define this 512 and 50 as overlay size. So let's create the chunks, and you can see it return again an array with documents, but this time it's not a single document. There are a lot of small documents with some data, right? But what we can do with those embeddings, with those documents, sorry. So we usually don't want to use it as it, so we can store that data into the vector database. But what actually a vector database is a type of database that stores data in high-dimensional vectors, aka embeddings. Each vector has certain number of dimensions. We can range from dozen or thousand, and depending on the complexity of the data. Some features of the vector database are fast and accurate search and retrieval. So most of the services provide scalability and performance, good performance, because there are serverless services, most of them, and support for complexity and unstructured data. Today, we will work with text embeddings, but we can use also image embeddings, video embeddings, audio embeddings. So let's compare traditional databases with vector databases. So in traditional, we use SQL and SQL to query the data. In vector database, we use similarity search or semantic search. In traditional, we use schemas, table, column, relation between documents, key value pairs. In vector database, we use high-dimensional vector embeddings. In traditional databases are efficient in exact matching query, and in vector database we use use the vector similarity and algorithms like nearest neighbor search. Traditional vector database really on B-trees and hash indices, and vector database use kitty tree and local sensitive hashing strategy. Some use cases for vector databases, you can create recommendation systems. Scenes are efficient to find similar items. So imagine a scenario like products or movies or some. So you can use it to compare with the user preference. Multimodal search, as I mentioned before, we are using today only for text embeddings, but you can store their image and audio and video embeddings. So you can, with a single query, you can retrieve different type of data. Even you can use, imagine the scenario, you can use an image as query and then get some related data from the vector database. For natural language processing, for sure, you can use vector database to store data and then create applications shows sentiment analysis, question algorithm system, and so on. And for fraud detection in financial applications, you can use a vector database to compare transaction or user behavior in order to identify unusual activity. There are many options in the market. So basically, but I just want to mention today is few of them. Chroma is a vector database that you can install in your server when your machine. Webit and Pinecone are both at serverless services. So basically, you can go to the page and create your account and get an API key, and then you can start using the service. Both have a free tier, but for production scenario, obviously, you need to pay as you go. And in MongoDB, you can create in your documents a specific field to store the embeddings, the generated embeddings, and then tell Mongo that you need to create a search index in order to apply a similarity search. So let's check a small example using Pinecone. Today we will use Pinecone. And so from LangChain, we will use Pinecone store. We will talk about vector store later, and we use the we need to import the Pinecone client from the Pinecone package. So let me run this code. We need to define the instance. We need to pass the API key. Once we have the client created, we can create our index. I won't create the index today because I already have created, but let me create the client. But basically, if you want to create your index, what you need to do is you need to pass the name, the index name, the name that you want. You need to pass the dimension that those embeddings will have. Remember that we are working with model embeddings. So this value should be the same value as the dimension that your model generates. So for instance, from OpenAI, the model generates 1,536 dimension, but if you use a different model like Mistral Embed, this value will change. You need to define which metric do you want to use to calculate the similarity between your documents. So as we did before, let's use cosine and some values regarding to the cloud provider. So you can define if you want to deploy during this in AWS in which region, right? So while we have our index created, we can get the reference. So now we have access to the index and we can do some operation. But let's check some Pinecone operation. You can describe a specific index. So calling the method describe index and passing the index name. It will show some information about the index. You can do some configuration. For instance, you can enable deletion protection, so no one is able to delete your index. So if you can see now that the deletion protection is enabled. You can for sure delete your index, but if the deletion protection is enabled and you try to delete, you will get an error. And also you can also disable it, right? From the index, reference that you get, you can call different methods. You can call observe to insert documents into your index, but we won't use it today because we use vector store a bit later. And also you can use update in order to change some data in a specific record, passing the record ID and some information that you want to update, right? So more about Pinecone. Pinecone works with namespace, so you can define many namespace inside your index. But if you don't define any, Pinecone will create a default namespace for you. So let's create a vector store. So LangChain provide kind of wrapper for each compatible vector database. So for Pinecone, LangChain provide Pinecone store that return a vector store. And what is a vector store? It's a wrapper that helps us to work with our vector databases to calculate, to do the CRUD operation and so on. So let's define our vector store. We need to pass the embedding, the model that we want to use to transform the data in embeddings, and we need to pass the reference to the index. So once we run that, now that we have the reference to, we have our vector store created, we can call add documents method and then pass the document that we want to store into the vector database, in our index. But since I already did that, I won't run this code, but here is how it looks like in Pinecone once you install your data, right? So one thing that we can do is, if we want to query directly using Pinecone client and the reference for the instance, we can call the method query. We need to define how many documents we want to get, and we need to pass the query, but we need to pass the query in form of embedding instead of text. So we can define some optional values to retrieve more information from our data. So if we run this, now we get some information, and the values are also the vectors that are similar to our query. But we can also use the vector store to get the documents that we want. Instead to call method query, vector store provide a method called similarity search, and we can pass the query as text, a simple text, and then we can define how many items we want to return. So here we run the query. Now we can see it returns an array with different documents regarding to our question. We can also use a similarity search with a score that will return documents, but we'll add a score metric that means how close these documents are to our query. We are doing different, we are calling similarity search, but what actually similarity and semantic search are. So let's say semantic search is a technique that understands the meaning of the query, the context and word and phrases, rather than just try to match exactly with keywords, right? Understanding with idea to get more relevant documents. It takes into consideration synonymous context and also the intent behind the query. There are two types of semantic search that we can use: sparse search and dense search. So sparse basically use high-dimensional vector, but with many zeros, focusing on SAS matching keyword, are good for simple queries, but doesn't have contextual understanding. Dense search is what we already did in the example using similarity method. Use vectors that capture the semantic meaning and the contents in order to provide better results. There is a third approach called hybrid that we can use that combine both sparse and dense. With hybrid, we can use sparse to get to find documents based on exact matches, and then reorder or rearrange using densers to provide more accurate data. So let me run this small snippet, and then we are getting information from the vector database, but we are doing nothing with that. So what we can do is pass this information to a model and then generate some answer using this information as context. So from LangChain, let's use chat OpenAI that helps us to use OpenAI models. I think by default is using 3 or 5 models, but you can provide any model name here, and then you can use, for instance, GPT-4 or GPT-4o, right? So we need to define the instance of the model, and we need to define a prompt. So from LangChain, we can use chat prompt template and to create a prompt. So the method from message receive a list of message, so you can create a system message to provide some role or to add some context to the model, and then the human message is the query that we will gonna pass to the model, right? But instead to pass the query directly, we will define some variables, so we can pass on dynamic information. The basic building block of LangChain is chain, and then you can define a very simple chain, use piping the model to the prompt. This is the very basic chain. So and then once you have the reference to the chain, you can invoke. Call the method invoke. You can pass some question, and you need to define the context. So remember, this context variable is the last query that we did to the vector database, and then here we run this. It's gonna generate some answer using the information that we are passing. Let's do a like example. Yep. So this small generation example will open the door to the last topic that we will cover today, that is retrieval-augmented generation. It's a technique in natural language processing that combines the retrieved document from the vector database with the text generation. So we need to, we should have two main components. One is the retriever, and one is the generator. The generator is basically a model, a large language model that can generate a content. That helps that language model to provide more accurate data with up-to-date data, and also using external sources. So that way we can increase the accuracy, the relevance of the task, such as question answering and summarization. Why RAG is important? Remember, even if OpenAI models like ChatGPT, GPT-4o, Anthropic Cloud, or Gemini from Google are so good, they are not perfect. Remember that they are static in time, means that the process to train those models takes some time, and also there are a lot of money involved in that process. So there are frozen in time. So there are no way that they probably they don't know nothing about the news about from the last week, for instance, right? So they lack of domain-specific knowledge. So they know nothing about your company data or your private data. So you need, we had a way to tell the model that use more recent data, up-to-date data, or your company private data, right? They function as black boxes because we don't know how they create the answers that they create, to be honest, and they are inefficient and efficient to produce. So just few companies are able to train and create a model from scratch, right? So let's check a sample of RAG. So this is how a RAG pipeline looks like. Basically, you have your private data. You need to use an embedding model, and also once you can transform that data in embeddings, you store that data in the vector store, and then your application can start to consume that data, right? So let's use some utility from LangChain again. Oh, here. Instead to load document one by one, we can use a different loader from LangChain called directory loader. So we load each file inside that directory, and based on the extension, we'll use file extension. We'll use a different loader, right? So I already load that information, so you can see that it load all of the file in the directory, and will provide the same structure array and page content, right? So from Pinecone, we need to get again the Pinecone store and the Pinecone client. We can define the Pinecone instance, and we should get the reference for our index in the vector database as well. Again, we can define the vector store as we did in the previous example. And all the process, you need to split the documents and so on. But we won't do that because I already did that. So now we will see an example. So let's define a query, and let's run the query, and we will get some information there, right? One thing that we need to take into consideration, not always that we run semantic search, we will get the best result at the first try, right? There are some strategy that we can follow to be sure that we are getting the better possible data from the vector store. So we can use re-rank to retrieve the retrieved documents. There are different strategies that you can follow to re-rank, but today I will show you how to use a different model to re-rank the data that you retrieve from your vector database. From LangChain, we can import Cohere re-rank model. So that will use a model from Cohere. You need to define, you need to pass the API key, the model name that you want to use to re-rank that data. Once you have the data, you can run the re-rank method, passing the retrieved document. Remember that these docs are these coming from the result of the previous query, and then you need to pass the original query, means the same query that you pass to the vector database. You need to pass to the same query to the re-rank model, and how many documents you want to retrieve, and you can see it will return an object with those objects are ordered by the relevance, so you can see, and the original index in the document that retrieved from the vector database, right? So here we look at this, we can see the original position of the retrieved document, and after the re-rank process, what would be the best option and the document most close to our query, right? Also, we can use another strategy called contextual compression. That means that instead to pass the documents as are when we retrieve from the vector database, we can compress each document. Compressing this scenario means to get the most important part of each document that are close to our query. So removing all noise. So we can use our vector database as retriever. Vector retriever is an interface, the return relevant document for using the query that we pass. So let's import from LangChain a utility called contextual compression retriever and LangChain extractor. So we need to pass to LangChain extractor method from a large language model, the model that we want to use, and then we have our compression, right? Or compressor, right? And then we need to define the contextual compression retriever, passing the generated compression and our retriever, right? And now we can do some query, and this is the query after removing the noise. Sorry, this is the document after removing the noise using the contextual compression retriever. Another thing that we can do is create a retrieval chain. Yeah, in the previous example, we are passing the context manually, but when we use the vector store as retriever, we don't have to pass the content manually. We just define the retriever, and the retriever get the data for us and send that data as contents to the large language model. So instead to OpenAI, we will use I will use Mistral on AI embeddings for this example, and then again we create a vector store passing the model and the index. Let's define a small system prompt with some instructions about the content that I want to create, and we define the slot for the context. Now we pass the user message with this small variable defined there in order to pass dynamic data, right? We can create the chain, the retrieval chain, create, again, we will use the vector store as retriever. We need to call the method create a stop document chain. Basically, this is the most basic retrieval chain. There are other more complex retrieval chains that we can create in LangChain, but this is the most basic one. We need to pass the model. We need to define again a prompt as we did before. Now, calling the method create retrieval chain from LangChain, we pass the stop chain and the retriever. And now we can do some, we can run this, we can create the chain. And here once we have the chain defined, we can use it to do some queries. For instance, the system query say create some slides with the data. So imagine that we use the language model as a tutor, so we can pass some query there now, and it will return some slide with the information that I am passing from. The retriever is getting from the vector database and passing as context. So using Mistral model instead of OpenAI, and you can see the answer is again slides with some data based on the query that we are passing. Basically, this is all I would like to share today.
So the first one is the following. So we use embedding models to get vectors for our training data and use our own vector DB to store the vectors. But what aren't we exposing our data to embedding models? Is there any way to secure our data privacy? What do you think about this question?
Remember that there are many options as well. You can use open source model to generate embeddings. I mean, I showed you example we using Mistral embeddings or OpenAI embeddings, but you can use open source models. You can download those models into your local machine and generate embeddings, for instance. So that way you can protect your data, for instance.
Okay, sure. And yet one more. Are any vector DB options available as installables instead of cloud if we wish to protect our data privacy? Let's say, for example, for HIPAA compliance.
For instance, the first vector database that I mentioned called Chroma, you can install it in your local machine or your servers. So yeah, you have the instance there.
Yeah, okay, cool. Well then, so I don't see any other questions. Nevertheless, guys, if you have some questions, please drop them into the comment section and Juan will be super happy to answer them all later on, I hope. Sure.